We can also use function notation when evaluating radical expressions. So for instance, we're asked to evaluate f of 0, f of 1, f of 4, and f of 9. For our original function, f of x equals the square root of x. So when we're evaluating this, we say, well, f of 0 equals the square root of 0. So well, the square root of 0 is 0. So we say f of 0 equals 0. F of 1 equals the square root of 1. The square root of 1 is 1, so f of 1 equals 1. F of 4 equals the square root of 4, so that f of 4 equals 2. And, f of 9 equals the square root of 9, so f of 9 equals 3. Now what we could do with all of these functions is we could use these 4 ordered pairs, 0, 0, 1, 1, 4, 2, and 9, 3, in order to graph this and see exactly what it looks like. It's good to understand what are different functions, what the graph looks like, what the general characteristics are. You can go ahead and graph this. I'm not really concerned about you actually knowing how to graph it, but you would just plot these 4 points and that would give you it. Now the other part of this is it asks you for the domain. And so again, we can look at domain exactly how we did in chapter 8. Our domain, what kind of limitation do we have on the square root of something, right? We said in chapter 8 that the radicand must be greater than or equal to 0. So here the radicand is just x. So we know that for the domain, I'll write that here, this is for the domain, x has to be greater than or equal to 0. So that means our domain is bracket from 0 to infinity, parentheses. Now another thing that we can also do, not really dealing with functions, but just dealing with evaluating radical expressions here. So when we evaluate a radical expression, square root of -3 quantity squared, first we want to evaluate underneath the radical. Well, -3 quantity squared is 9, and then we can take the square root of 9 as 3. Here we have something a little more complex. We have the square root of 36x squared. So what we can do is we can actually split this up. We can take the square root of our number, 36, and the square root of x squared. So the square root of 36, numerically we know, is 6. We're timesing in between here, so then we're timesing in between our radicals. Well, what's the square root of x squared? Well, what squared equals x squared? And that would be x. So our simplification here is 6x. The next